Hello everyone, welcome back to Mr. Lee's Math Class videos. I'm Mr. Lee. This is Math 1316. We are still in section 5.3. This should be the fifth and last video. So we've learned how we evaluate special angles, but not every angle is going to be a special angle. So we're going to have to figure out ways where we can do this. Now, the key to remember on these is these are things that you can do in the calculator. Anytime they tell you to round a certain number of decimal places, that's what they want. The real question is there's some things we have to do on the way. Regardless of whether you have a scientific calculator or a graphing calculator of some kind, you'll notice that there are actually only 3 trig buttons on the calculator. Which means it's really easy if you have sine, cosine, or tangent to toss them in the calculator, but if you have secant, cosecant, or cotangent, then you need to be able to convert them into one of the other ones. So for example, sine of 49 degrees and 12 minutes, we would probably convert that to decimal, so we'll take 12 over 60, which is actually exactly 0.2. We'll do sine of 49.2, and you literally just type it into your calculator. One thing to note is you might need to check the mode. And there will be a radian or degree mode. You want to make sure you're in degree mode when you're doing this because radians will be different, which we'll see later. So the sine of 49.2, you just toss it in and you get to 3 decimal places that this is approximately 0.757. Secant, however, doesn't work the same. So secant of 97.977, we know that secant and cosine are reciprocals. So the secant of a value is 1 over the cosine of that same value. So when you need to put these into the calculator, you have to convert them into the reciprocal, which means if they're in the numerator, they go to the denominator and vice versa. So that means the cotangent one will go back up to the numerator. So you do 1 divided by the cosine of 97.977 degrees to get value negative 7.026, or negative 7.206, excuse me. Now, I'm going to leave C and D for you to practice. One of them straight into the calculator. The other one, again, you're going to have to convert it just the opposite. And of course, I'll upload these. Now, if we're going backwards, again, look at the calculator. Just like there's only sine, cosine, and tangent, there's also only going to be an inverse sine, an inverse cosine, and an inverse tangent. So this gives us a little opportunity to talk about those functions. Inverse sine does not mean the reciprocal of sine. It does not mean cosecant. So the trig functions take angles and spit out ratios. The inverse functions on the calculator take ratios and then spit out potentially angles. So what we're really trying to do here is simply saying they're like square root and squared, inverse operations. So in order to get rid of a sine, you need to take the sine inverse. But in order to take the sine inverse on one side, you need to take the sine inverse on the other side. On the left, it's like square root and squared. They'll cancel out. So you get theta is the sine inverse of 0.9677. And that goes into the calculator. There is a sine inverse button, a cosine inverse, and a tangent inverse button. So we do the sine inverse of 0.9677 to get that angle is actually rounded to, it doesn't say how many decimal places, so we'll round to 2 decimal places, 75.40 degrees. And you can always confirm this by taking the sine of this angle in the calculator and seeing if it's close to that. Of course, with rounding, it might be slightly off. If secant of theta is 1.0546, again, this causes a problem because we don't have a secant inverse button, which means we need to convert our secant into cosine, knowing it's the reciprocal, kind of like the problems from before. So the cosine of theta now is 1 divided by 1.0546, which means, again, just like we took the sine inverse, we can now take the cosine inverse. So this is the cosine inverse of 1 divided by 1.0546. And again, then you go to the calculator. You can simplify along the way, but one thing to be careful of is that rounding anytime can cause your answer to get more off later. So just be careful with that. And we find that this theta is approximately 18.52 degrees. And C is similar. Again, cotangent needs to be turned into tangent, and you work from there. There are also some interesting applications of the trig functions. There's some physics applications. Grade resistance, which we see, it's like the angle of a hill. So if your automobile is traveling up or downhill, it experiences grade resistance. It's modeled by the function, the force of the resistance is equal to the weight of the object times the sine of the angle, because the sine gives us the vertical component. Naturally, if you're going uphill, you're going to experience some resistance. If you're going a negative angle, you're going downhill. We'll see what happens there as well, but you can expect it's going to probably try to send you down that hill. So this is really just about plugging these in and some logic questions on C and D. So find the grade resistance for a 2,500 pound car on the hills of different angles listed below. So you really just take the weight times the sine of the angle in question. So the force equals 2,500 times the sine of 2.5 degrees, which you then toss into your calculator. And you get that our force is approximately 109.05. It's a force, so it's units. We are in pounds, and an angle. So our force is probably 109.05 pounds of force. What that really means is that 109.05 pounds of force are being applied downward. So that's kind of like what you're fighting against if you're trying to drive up the hill. Meanwhile, if you do this with a negative, 2,500 times the sine of negative 6.1 degrees, you actually notice that your resistance on this one ends up being negative 265.66 pounds, which tells you that about an equivalent of 266 pounds of force are trying to drag you down the hill. These two you should be able to figure out more logically, but you can plug them into the calculator. If you are driving on a 0 degree, that's a flat horizontal, how much of your force is trying to force you in any direction here? The answer is none. There's none, and you can plug it in and see that. You should have 0 pounds of force because you're driving horizontally. Meanwhile, a 90-degree angle is completely vertical, which effectively means you're lifting that 2,500-pound car, which means how much weight are you actually going to have to lift? All 2,500 pounds. And the sine of 90 degrees is 1 and does reflect that. You're also going to have a few equations in the homework which are asking you about these. It's not super important that you do anything but put these in the calculator. Later on in a future chapter, we'll see why these values are the way they are because they have equivalent statements, but for now you're just tossing them in the calculator and it should produce an interesting value. So sine of 35 degrees, cosine of 55 degrees, plus sine of 55 degrees, cosine of 35 degrees, produces an answer of 1. And we will see why that is later. So you can just practice the other ones, putting them in your calculator. And then finally, we are done with section 5.3.